Alright, the test is going to be this Friday, and the first part of the test is vocabulary, and there's 29 points off of that. The first part would require you to be able to look at a graph and remove all this information from it. The first thing is the vertex, and the vertex would be the middle point, which is right there. And as you can tell, the vertex is a point, so you need an x value and a y value. And this one right here, and the x value is -1, and the y value is -9. The word zeros also means x-intercept. So in this test, when they say find the zeros, all they're really looking for is the x-intercepts. If you look over here, the x-intercept is 2, and the x-intercept is -4. How you could tell? Because this is the x-axis. Now, zeros are not written in dots like this. Zeros are written in x equals, and that will be x equals 2, and x equals -4. So you would not need to use these for the zero. The y-intercept. For the y-intercept, you're looking for where it intercepts the actual y-axis. This is the y-axis, and it's only being intercepted right there. Now, this is a point, so we're going to be looking at 0, -8. Axis of symmetry. An axe is used to cut the parabola in half. If it cuts it in half, notice how it crosses the vertex, which means I can get the answer just from the vertex. Axis of symmetry is an x, so that's x equals the x value, and the x value right here is -1. So you can always get the axis of symmetry from the vertex, or you can see where it crosses the x-axis, which is also -1. Symmetrical points are points that have the same y value. They're points that have the same y value. You can find them by just looking across each other. So these right here, these are right across from each other. These are symmetrical points. These are symmetrical points. But you want ones that are right on the edge so you can actually tell exactly what they are. For example, this is 1, -5. And these points right here is -3, -5. And notice how they have the same y. So this y is -5, this y is -5. Alright. The next one is again another set of vocabulary words. And what they want you to do here is to sort the words into two categories, either linear or quadratic. So some of them will go in both. We'll start off with vertex. Vertex is a quadratic word, because the line is straight, it doesn't have a vertex. A parent function. Well, the linear parent function is y equal to x. But the quadratic also has a parent function. And that one's actually y equals x squared. So parent function goes to both of them. Zeros. Zeros are x-intercepts. So you can have an x-intercept for a linear and an x-intercept for a quadratic, because they both can cross the x-axis. Coefficient. The coefficient is whenever you have a number in front of the x. So you can have a number in front of the x squared, we call that a coefficient. We can have a number in front of the x, we call that a coefficient. So both of them also have coefficient. There's going to be a matching question on the test that's worth about 12 points. So this is why we're doing this. It's vocabulary. A y-intercept is wherever you cross the y-axis. A line can cross the y-axis, and so can a parabola. A slope. Okay, now we found a slope for linear, but if you notice, we did not talk about slope for quadratic, so we're going to leave that one alone. Axis of symmetry. This is a line that cuts the parabola in half, so guess what? That's quadratic. Increasing. Increasing means going up. Some lines go up, and 1/2 a quadratic equation can go up, so that goes for both. Symmetrical points. Now that was something only for quadratics. And the rate of change is another word for the slope. And that's also linear. Alright, I hope this helped. It's just to define these words for you, because that's a big part of the test and a lot of points. So let's make sure that we know these words for the test. Now, here we found all this stuff from a graph. Here, we're going to find all this stuff again, but this time from a table. The only thing different is with a table, you always want to do the rainbow method. It really helps you to see things. Alright, now the negative 16 should probably be right here. Alright, now knowing all this, everything has a symmetrical pair, so the only point that does not, that will be your vertex. So 0, 2 is our vertex. Remember, zeros are weird. You don't really want to use these to find the zeros. You want to write down x equals, and again, y, because the zeros are just another word for x-intercept. And they're just written differently. So for the zeros, all I'm really looking for is an x-intercept. And as you can tell, an x-intercept will always have a 0 here. So all I'm really looking for in that table is wherever the y is 0. So this is the y, that's a 0. So the trick I do is I circle the 0 and draw an arrow towards the x. That reminds me that that's the x-intercept. And if I find a 0 over here, I like to draw an arrow to the other side to remind me that that's a y-intercept. So the x-intercepts are negative 1 and 1. And for the y-intercept, 0, 2. Again, these are just written differently because that's the way they want zeros to be written. Axis of symmetry. Again, remember, an axis of symmetry is a line that cuts it in half, and we can always get it from the vertex. So I'm going to get my axis of symmetry from the vertex. I want the x value. That will be 0. Symmetrical points are any points that have the same y. So I draw an arrow to the y right there. All these got the same y. So I could pick any one of them. So let's pick the negative 6. Negative 2, negative 6. Positive 2, negative 6. And they both have negative 6 as their y. As you can tell, the majority of this test is going to be on these, and they're really, really, really easy. Now, there's also going to be some questions on the parent function. Those are going to be only 4 points. What they want you to do is name the quadratic parent function. That's easy. That's y equals x squared. We just talked about that. Then they ask you for 2 points on the quadratic parent function. Then they ask you to name the vertex of the quadratic parent function. I don't have to memorize these. I mean, I could, but I don't have to. Because what I have is a quadratic parent function. So on the test, whenever you see the word quadratic parent function, cross it out and write down y equals x squared. Because we want that to be a way for you to remember that all you have to do is go to your calculator and put y equals x squared. So now once you do that, now you can go right here and you can graph it. And you can sit there and look at the table and find any answer that you want. There's your vertex. Looks like a 0, 0. But if you want to make sure, you can just do the rainbow method. See that? 0, 0 is the only thing that's open. Now, give me any 2 points. Well, you can pick as many 2 points as you want. 2, 4, 3, 9, 4, 16. So the trick to getting these 4 points is whenever you see this word, just write that down, think calculator. Alright, for domain and range, this one gets a little bit harder. Because in this case, what you have to figure out is what are they asking for and how do I need to write it down. There are 2 different ways to do it. If you have endpoints, then you got to draw a box. When there's no arrows, that means you could go ahead and just draw a box. When you draw the box to fit everything in there, like a rectangle, the rectangle will give you all the answers. Now when you have an arrow, then you have to deal with infinity. That one's a little different. So, no arrows, draw a box. And whenever you draw a box, you're going to go ahead and give me the domain. That will be the x. And then you have to give me the range. That will be the y. So all I need are the numbers to go here. Let's take a look at the x. As you notice, the box starts off right here in negative 3. And that's a closed point. That means it has that thing down here. And then the x, it ends on 1, 2, 3, 4. And that's an empty point. So that means it does not get a line right here. Let's start the y. And the y goes negative 1, 2, 3, 4, 5, 6, 7, 8. It starts off in negative 8. And again, that is a darkened point. See, there's no circle there. You go to the top, 1, 2, 3, 4, 5, 6, 7, 8. That goes to positive 8. But that one has an empty point. See how that's not filled in? So you do not get to put a equal sign on this one. Alright, so this is the way that you do the ones without an arrow. Now once you get to the ones with an arrow, we're going to have a different issue here. Okay? Why? Because the arrow means that it keeps going and going and going and going. So what we're going to have to do is find out some of the limits to it and try to figure it out. The top has no arrow, so I get to draw a line just like I did in the box before. The left has no arrow. I'm sorry, the right has no arrow, so I can also draw a box. But this keeps going all the way down, which means I can't draw this line because it keeps going. I don't have an end to it. And it also keeps going to the left. You see how it's going left also? So I can't draw a line right here. So the only two limits I could use is this one and this one. So now I'll write down the answer. We'll start off with the x. For the x, all I know is I can get all the way to -9. And then I can't go all the way to the left. It goes at infinity. So what does that mean? That means x is going to be less than -9. Positive 9. Okay? How'd you get that? Well, the only thing that we have is 9, and then it starts going left. All the way to, what is that, -7, 0, -1, -2, -3. And if it keeps going down there all the way to the left like that, it'll go all the way to negative infinity. So that means it starts off at 9 and just gets smaller and smaller and smaller and smaller and smaller. There's no line here because this one's empty. Now we're going to take a look at the y. Now the y, we have the top number. The top number right here. That's the line. It crosses the 2. Now, when it gets to 2, it also keeps getting smaller. 2, 1, 0, -1, -2, -3, all the way down. So again, it's less. But this one's actually shaded, so it gets a line. So as you notice, the domain is a little bit harder. You have two options. One with the box, one with like half a box because the other sides are not there because we have an arrow. And what you have to remember is this is what this one would look like, and this is what this one would look like. If you get a point that's shaded or just a line, you draw it like that. If you get an empty point, you draw it like that without that line in the bottom. Table, 6 points. Find the missing value. Now, how can you tell if something is linear, if something is quadratic? And that's easy. You take these numbers and just subtract them from each other. Now, in this case, we have to find the missing value. So we're going to have to do the normal thing first, then come back and try to figure out what this value is. That's pretty easy. 46 minus 20. Again, all you got to do is just plug in the calculator and press enter. And that would actually give you 26. And 20 minus 20 is 18. And 2 minus -8 is 10. Okay, so obviously it's not linear. So we got to go to the second round. 26 minus 18 is 8. 18 minus 10 is 8. Great job, it is linear. So now we're quadratic. So we know it's quadratic. And since we know it's quadratic, we know that this is 8 and this is 8 and this also should be 8. So whatever's over here is bigger than 26 by 8 points. So we're going to go to our calculator and go 26 plus 8. That means this should have been 34. Let's check it. 34 minus 26, that does give me 8. Alright, cool. Which means whatever this number is, it had to be 34 bigger than 46. So I go over here and go 46 plus 34. And that gives me my answer, which is 80. So the missing value is 80. Just to be sure, you can just kind of look at these numbers. -8, and then gets bigger to 2, gets bigger to 20, gets bigger to 46, gets bigger to 80. How can I tell it's quadratic? This one minus this number gives me this minus that gives me that, this minus that gives me that, this minus that gives me that, and they all have the same common difference right here. So this is the way to work this out, and there's 6 points on the test off of that. We're almost done. The last part is transformations, and you have 56 points off of that one. And transformations when something goes up, down, left, right. If it's bigger, we call that compression. If it's skinnier, we call that stretch. Again, we can also just call this one wide. We can also call this one narrow. And flip. We call this reflection. So really you're looking for one of 7 different things that can happen, or any combinations of those. We'll start right here. Given y equals 3x squared plus 7, what would happen if the coefficient, now that's a word we talked about a second earlier, that's the number in front of the x squared, or the x, is changed to 7. So let's go ahead and take a look at that. We have y equals 3x squared plus 7. This is the coefficient. What happens if I change this to a 7? Well, you know what? I know it won't go up or down because that's these numbers. I know it won't go left and right because there was no parentheses. I know it's not going to flip because we didn't change the signs, so it has to either be wider or narrower. Now the best way to do this is just use your calculator. Let's turn it on. Go to y equals, and we'll start off with 3x squared. And then we're going to change that to 7x squared. Then we're going to graph it. Here's the first one. This is the 3x squared. And here's the second one. Here's the 7x squared. That looks skinnier to me. So I would say it became narrow. Now, when I taught this in class, what we did is we went ahead and told them that the numbers next to the x squared are opposite. So if you're going to multiply, it doesn't get bigger. It gets skinnier. Alright, what happens if it's changed to negative 5? Let's check that out. Y equals 3x squared plus 7. And y equals negative 5x squared plus 7. So again, we didn't say anything about changing the constant, just changing the coefficient. So it changed from a 3 to a 5. That means it got bigger, just like right here. And whenever it gets bigger, it gets narrower. But one more thing happened. It changed from a positive to a negative, which means it was also reflected, which means it flipped. And again, we don't have to guess these things. We could just kind of graph them and find out. So we're going to change this to negative 5x squared plus 7, just like that. And here they go. Alright, here's the first one. As you notice, the second one is skinnier and is flipped. Now, it's kind of hard to tell that it's skinnier because it's been moved under it, but if they were flipped in front of each other, you could tell it's skinnier. So this is why we both need the calculator and the rules. Okay? When something moves up, you add at the end. When something moves down, you subtract at the end. When something moves left, you need a parentheses. And this is opposite. So plus actually goes left, and minus actually goes right. To be wider, again, this is also opposite. 1/2, or a fraction, anything smaller than 1, makes it wider. And when you multiply with a number bigger than 1, it actually makes it narrower. So these are opposite. These are opposite. This is the only one that's not. And the reflection, if it has a negative in the front, that's when it flips. So, this is not enough. You have to also know that. Let's go to number 2. Given a y equal to, and again, it makes no difference what's out here. If it's a y equal to equation, you should think of using your calculator. Find the vertex, minimum, maximum, does an up and down x symmetry and 2 symmetric points. So for that one, I'm going to need to use a calculator. Again, I could probably still look at it and figure out a lot of information. But when I use a calculator, I'll have different options. Alright, let's graph and take a look at the picture, and then we realize that we can't really tell. Because the picture is way too big. Now, I could either zoom in, but that's no good either. Because when you zoom in, zoom out, you can't tell the notches anymore. You see how this is too solid? So that's not going to help you either. So what we're going to do instead is we're going to go ahead and just use the table. So, the graph won't help, then we're going to use the table. Alright, and whenever you have a table, really what you're going to be looking for is whenever you can find any points that are symmetric. So, oh, there it is. See, I just have to move around a little bit to see points that are the same. These are 17s, these are 22s, these are 25s. which means my vertex is 326. Now, we're going to go ahead and find is it a minimum or maximum. Now, for that one, we could look at the graph. As you can tell, the vertex is going to be on top, and if the vertex is on top, it's a maximum. So whenever we're looking for a minimum or maximum, we only look for the vertex. We don't look at the lines or the arrows, just the vertex. Does it open up or down? As you can tell, the arrows are pointing down. So this one opens down. Axis of symmetry, we get that from the vertex, the x value, and the x value is 3. And two symmetric points are any points that have the same number. And that was pretty easy. These both have 17. So that's 0, 17, 6, 17. Now watch this. Same y. This one has the y of 17. This one has the y of 17. They are symmetric. Alright, number 3. Give an equation that is 5 units higher than y equals negative 1/3 x squared plus 7. Now, this makes it narrow or wide. This makes it flipped. So I'm not looking at these numbers. Okay? I'm only looking at this number. So I start off at 7. And I want to go 5 units higher. So I add 5. 7 plus 5 is 12. Be careful. They don't want this. Because they're not asking you what it is at 5 units higher from the parent function. They want it 5 units higher than this number. So you go find this number and add 5 to it. There's your answer. Alright. Now, give an equation that's 3 units to the right of this. Now again, remember, this makes it narrow or wide. In this case, it's going to be narrow. This makes it go up or down. In this case, it goes up 7. But the left parentheses and the right parentheses teaches you whether it goes right or left. This is going to go to the right, because remember, this is opposite. Here's a 0. Here's negative 2. It looks like it's to the left, but opposite of the left is right. This is actually to the right, too. So if I take this and go 3 more units to the right, what would that make it happen? That would make it negative 2. Subtract 3, because remember it's opposite. When you add the subtraction, it becomes negative 5. So this becomes y equals 3x minus 5 squared plus 7. Okay? It's kind of weird, but 3 to the right, just take that 2, add a 3 to it, that becomes 5. Okay? Let's check it. A lot of these, what you really have to do is just kind of use your calculator and just check it out, the answers. One of them is going to work out. Here's the first one. Now what we said is that the second one's going to move 3 to the right. So let's check it out. I'm going to grab the second one right under it. And we're going to look at the picture. Here's the first one. That's to the right. Here's the second one. It's further to the right. I was correct. Alright, number 5. What is the new vertex when you shift the graph 5 units to the right? Alright, now this one's different. Because here, you had the parentheses that told you left and right. Here, there's no parentheses. There's no way you could do this on your own. So this one, you need to use the help of the calculator. So I go over here and I graph the first one. Negative 5 x squared plus 3. Now, once I graph it, I can actually find the vertex. And that's pretty easy. The vertex is 0, 3. Now, if I want to take this and move it 5 spots to the right, 1, 2, 3, 4, 5, right? It'll be right here. Now, the new point will still have the same y, just the x changed. So that would be 5, 3. So this one, we just kind of look at the calculator and figure out from there. So, you can graph in the calculator, try to do that. You can always check your answer like we did over here, or you can always find your answer like we did over here. Number 6 says, given the equation of this, name the vertex and any point. Again, this is easy. A lot of this is just starts off with y equals. This button right here says y equal to. Well, it used to. So you go over here, and you just type it in. once you do that, you can just graph it. I can actually see it, but it's kind of hard to count all these notches. It looks like -4. So I'm just going to go over here and use the table. It's just a whole lot easier. Until I see numbers that start repeating. There we go. Symmetric point, symmetric point, symmetric point, vertex. -3, 9. Now, they want any point. Okay, how about -6, -9? That's a point. And that's how we find the answers. Just use your calculator. So, transformations are 56 points. Calculator is your friend for these. Just go ahead and check them out and give it a shot. The last thing we're going to work on is using a double graph to find the vertex and find out how the graphs change. Now, just because I give you this, it doesn't mean you put all your concentration here. I also gave you this. You can already tell me how they changed by just looking at the equation. It was +2 and became +5. That means it went up 3. I don't need to figure that out by looking here. Or, I can notice that everything here is +3. So you can find the first answer any way that you want. 29 plus 3, that's not 29, it's 32. It's 32, 14 plus 3 is 17, 5 plus 3 is 8, 2 plus 3 is 5, 5 plus 3 is 8. So you can tell that it went up 3, either by looking here or by looking here. It's easier here though. Next question is find the vertex, and that's easy. Use your this is for Y2. Use your rainbow method. Same thing right here. This one's Y1. Okay, guys, this is the majority of the test. If you guys were able to follow through with me, that would be great. If not, make sure you ask your teachers. And good luck on your test.